Okay, section 5.2, linear system, solving by the method of addition now. And we call this elimination by addition. Okay, now you don't have to write this down. I just want to show you something. Here's what we want to do in elimination by addition. What we want to do is we want to have a system that looks something like this. Now, here's what we want to happen. I want to add the two equations together. But here's what I want to happen. When I add the two equations together, I want one of the variables to be eliminated. So like right here, if I added the x's, what is 3x plus 2x? It's 5x. What is negative 7y plus 7y? It adds out. So in other words, the y's are eliminated when I add them together. This is what I want to happen. Now, here's why I want that to happen. Because if you add the two equations together, you would get 5x. The y's are eliminated, equal 10. Then you can find x and then take that number, plug it back in for x and find y. So that's the idea of this method. Now, here's the problem. Sometimes that doesn't happen by itself. So like right here, if you add these together, you get 12x. If you add these together, you get plus 4y. So is either variable eliminated? No. But remember, one of the golden rules to an equation is this. You can multiply an equation by any number you want to as long as you multiply every term on both sides. So here's the objective. We want to get the numbers in front of x to be the same, but you want one of them positive and one of them negative. Or you want to get the numbers in front of y to be the same, but you want one positive, one negative. Now, let's look at this. Look at the 5 and 7. Can I multiply 5 by anything to get 7? No. Can I multiply 7 by anything to get 5? No. But look right here. What could I multiply this by so that this number is the same as that number right there? What would I have to multiply that by to get it to be a 6? If I multiply it by 3. So here's what I'm going to do. I'm going to take the bottom equation, the whole equation, and multiply it by 3. Now, why am I multiplying it by 3? So that the numbers in front of y are the same, but one's positive and one's negative. So if I multiply this by 3, you have to multiply the whole equation. So 3 times this, 3 times this, 3 times this. Now, I'm not going to touch the top equation. All right, so what I'll do, leave the top equation alone. Now, when you multiply the bottom equation, 5 times 3, 15. 3 times 2, negative 6y. 3 times 4 is 12. Now, you can add the two equations together. I'm not finishing this right now. We are in a minute, but not right now. So now you add these two equations together and the y's are eliminated. Then you find the answer for x, plug it back in, and find y. Okay? Let's do a couple more like this, and then we'll work an actual problem. Okay, right here. Can I multiply 6 by anything to get 11? No. Can I multiply 11 by anything to get 6? No. All right, look at the x's. You got a 4 and a 12. What would I have to multiply by to get these two numbers to be the same? Well, if I multiply this by 3, because what's 4 times 3? It's 12. So if I multiply this by 3, I would have a 12x right here. But remember, you want them opposite in sign. Here's why. If this is 12x and this is 12x, 12x and 12x doesn't eliminate the x's. 12x and 12x is 24x. So you need it to be a 12x and a 12x, but one of them has to be negative 12x. So when you multiply right here, when you multiply by 3, just multiply through by a negative 3. And that'll make that be negative 12. But when you multiply by negative 3, you have to multiply the entire equation. So what I would do in this problem is multiply the top equation, this whole equation right here, by negative 3. All right, let's do that. So negative 3 times 4 is negative 12x. Negative 3 times 11 is negative 11, no, I'm sorry, negative 33y. And negative 3 times 9 is negative 27. Now, don't do anything to the bottom equation. Now, when you add these two equations together, your x variable will be eliminated. You can find y, and then take that number and plug it back in to find your x. Okay, let's do one more. Every now and then, you are going to run into a problem where you may have to multiply both equations by something. For instance, can you multiply 2 by anything to get 3? No. Can you multiply 3 by anything to get 2? No. Can you multiply 5 by anything to get 2? No. Can you multiply 2 by anything to get 5? No. So in this case, you're going to have to multiply both rows by something. So let's talk about what we would do in both cases. Let's suppose I wanted to eliminate the x's first. 3 and 2. Give me a number that 3 and 2 both divide into. 6. So here's what I want to do. Get this to be a 6 and this to be a 6. In order for this to be a 6, what would you have to multiply by? 2. In order for this to be a 6, what would you have to multiply by? 3. So multiply this by 2, this by 3, that would make both of those be 6s. Now, remember, they have to be opposite in sign. So you would have to put a negative with one of those two numbers. So one option, if you eliminated the x's, I'm not going to actually do this, but if you wanted to eliminate the x's, multiply the top one by 2 and the bottom one by negative 3. And then that would make this be 6 and this be negative 6. Now you got to do the whole equation. That's if you eliminate x. Now, suppose, instead of eliminating the x, suppose I said, you know what, Mr. Ryan, I think I want to eliminate the y's. All right, let's see what we would have to do. 5, you can't multiply 5 by anything to get 2, 2 by anything to get 5, but you can get both of these to be 10s. So what would you have to multiply this by to get a 10? 5. What would you have to multiply this by to get a 10? 2. So if you multiply the top one by 5 and the bottom one by 2, that would put 10s right here. They're already opposite in sign. So one of them doesn't have to be negative. So if I eliminated the y's first, I would do that. Now you're going to see in just a second, you can pick whichever variable you want to eliminate first. But how do you eliminate it? By multiplying. All right, so let's look now at our first example here. Now, some books call this the elimination by addition. Some books just call it the addition method. Some books just call it the elimination method. But elimination or addition or elimination by addition is all the same. All right, so let's look at this problem right here. Okay. Before I give you the steps, let me say this. if you'll look back at the substitution method that we did a while ago, the first problem we did a while ago by the substitution method was this one. The reason I'm working this one is I want to show you that they both give you the right answer. So if I was going to give you this on test, I would probably tell you to do the substitution method. But let's follow the instructions just to see you get the same answer. All right. The answer that we did a while ago was 1 comma negative 2. So we should get the same answer when we use this method. Okay, here's the steps. Step 1. Eliminate your variable of choice by multiplying the equations by an appropriate number. Okay, so let's see if one of these is easier than the other. 3 and 2 both go into 6, so I'd have to multiply both of these by something. 1 and 3 both go into 3. So if I want to get rid of the y's, all I got to do is get this to be a 3. They're already opposite in sign. So it would be easier to eliminate the y's first and not the x's. So let's eliminate the y's. All right. I'm going to call this equation up here E1 and this equation down here E2. E1 stands for equation 1. E2 stands for equation 2. Now let's write out what we're going to eliminate. Eliminate y by multiplying, all right, let's see. So you've got to do 3 times this right up here. So 3 times E1. All right, we're not going to bottom with E2. So let's put E2 back down. Okay, multiply 3 by E1. 3 times 3, make sure you multiply all of them. 9x, 3 times y is 3y. And then 3 times 1 equals 3. That's step 1. All right, step 2. Add the two equations together. Okay, so let's do that. Let me back up. Add the two equations together and solve. Make sure you add those two words. Add the two equations together and solve. All right, so we want to add them. 9x plus 2x is 11x. The y's add out equals 11. And solve. So, we're halfway there. Now step 3. Substitute the value from step 2, right here, back into one of the original equations to find the remaining variable. So what I'm going to do is I'm going to take this number, come back to either one of these, it doesn't matter which one, and I want to plug this number in for x, either right here or right there, and find y. Doesn't matter which one you pick, so pick the one with the smallest numbers. So look, E1, the numbers are a little smaller than E2. So I'm going to plug this into E1. So let's write E1 back down. Plug 1 in for x. So that would be 3, and then subtract the 3 across, and 1 minus 3 is negative 2. And then step 4 is the same as it was in the other. Write your answer as an ordered pair. Now you said, Mr. Ryan, I got a question. What if we had plugged it into E2 instead of E1? You'd have still got the answer negative 2. You'd have got the exact same answer. Okay? Let's do another one. 5x plus 2y equals negative 16. 4x minus 3y equals negative 22. Okay. First, you've got to decide what you want to eliminate first. Do we want to eliminate the x's? 5 and 4 both go into 20. So you'd have to get these to be 20s. But one of them needs to be negative. Now look at the y's. 2 and 3. They both go into 6. So we can either eliminate the x's by getting these to be 20s or eliminate the y's by getting these to be 6. That would be easier to me. So let's get rid of the y's. Now, if they had both been positive, you'd have had to multiply one of them by a negative number. But since they're already opposite in sign, I don't have to multiply one by a negative number. So here's what we're going to do. Eliminate y by doing what? What are we going to have to multiply by E1? All right, this is a 2. We need it to be a 6. So I'm going to take 3 times E1. And now we need this to be a 6. So what do I multiply that by to get that to be a 6? A 2. So I'm going to take 2 times E2. But it has to be the whole equation. Now let me say it one more time. If this had been a plus, I'd have had to put a negative with one of these so that they would add out. All right, so let's take 3 times E1. 3 times 5, 15. 3 times 2, 6y. 3 times negative 16, negative 48. Now take 2 times E2. 2 times 4, 8x. 2 times 3 is minus 6y. 2 times negative 22 is negative 44. So that's step 1. Step 2, add the two equations together. And when you do, the y's add out. 15 plus 8 is 23x. Negative 48 minus 44 is negative 92. And solve. That divides evenly. Now step 3, plug this back into either E1 or E2, whichever one you prefer. E1, the numbers look a little smaller, so I'm going to take it. Plug negative 4 in for x. So this would be negative 20 plus 2y equals negative 16. Add 20 to both sides. So that would be negative 16 plus 20, which is 4. And then divide by 2 to get 2. And so this is the ordered pair, negative 4, comma 2. You always put your x first and your y second. And if you take these two numbers and plug them back in, it'll make that equation true and this one true. So that's solving a linear system by the method of elimination, or elimination by addition. Same thing. All right. Now, I'm going to do two last examples to close out this section. And these two examples that I want to show you, if you'll notice in all four of the problems that we worked, you got, in every one of these, it was this case, where you had a single point of intersection. What I want to do is I want to show you how you can tell. Remember, there was 3 possible outcomes. It was an ordered pair, but there's 2 other options. No solution or infinitely many ordered pairs. What I'm about to do is show you how you can tell when you're in one of those 2 cases. So, let's write this problem Okay, so let's use the elimination method. All right, let's see. 2 and 10, get both of these to be 10s. All right, so I'm going to eliminate the x's. All right, I need this to be a 10, this to be a 10. What do I have to multiply by to get that to be a 10? 5. But I need it to be negative 10, so I'm going to eliminate x by taking negative 5 times E1. This is E1 right there. All right, so let's do that. Negative 5 times 2, negative 10x. Negative 5 times negative 3 is plus 15y. Negative 5 times 1 is negative 5. Now the bottom equation. 10x minus 15y equals 2. All right, I want to add the equations together. When I do, both variables cancels. So there's nothing left on this side. Okay, that's the first time we've seen this happen. Whenever this happens, when both variables are eliminated, your answer will either be no solution, there's no answer at all, it's never true, or the answer is infinitely many ordered pairs. How can I tell? Read your bottom statement. If it is always false, it's no solution. If it's always true, it will be infinitely many solutions. So read this. 0 equal negative 3. Is that always true or always false? Is 0 ever equal to negative 3? No. So this problem right here would be no solution. Now, it may not say 0 equal negative 3. It may say 0 equal 5, 0 equal 8, 0 equal 15. But it will be 0 on the left equals some number. Anytime that happens, it's no solution. So if I was to graph these two lines, I do not want you to, but if I was to graph these two lines, they're parallel. That means that they never cross. So if the variables cancels and it's equals some number over here, it's no solution. Now, let me show you how you can tell when you're in the other case. See, there's no way of just looking at it and telling at the beginning. You have to try to solve it. Okay, so let's do one more. Let's solve this system. Let's get rid of the x's again. This is a 2, so I'm going to get this to be a 2. But it needs to be negative. So let's take negative 2 times that bottom equation. Leave the top one alone. All right, when I add them together, both variables cancels. But so do the numbers. When the variables and the numbers cancels, that's when the two lines lie directly on top of each other. When this happens, the answer is this: infinite. Infinitely many ordered. That's the I there, sorry. ITI. So you're not going to know before you work the problem if it's going to be no solution or infinitely many solutions. If all the variables cancels and the numbers don't, it's no solution. The lines are parallel. But if all the variables and the numbers cancel, it'll be 0 equals 0. In that case, it's the same line, so it's infinitely many solutions. But a majority of your problems, when you solve them, will fall into that first case. But you must use either the method of substitution or elimination by addition. Make sure you know both methods because I will ask you the methods on the test, and if you do not use the right method to work the problem, you receive no credit. So make sure you know how to use both of these methods. This completes section 5.1.